Hello. Hi guys, I hope all of you are doing well. So I welcome you all to yet another video of Databricks playlist, and in this particular video, we are going to see about join operation. We are going to see what exactly join is and how many kinds of join operations can be performed on a data frame. So Spark gives us multiple options for join operations, and we are also going to see how all those join operations are different from each other and what will be the output of those join operations. So let's jump right into our video and let's get started with the join operation. So before jumping on to the coding part, I would like you to first of all visit on the official documentation of the join operation, which is provided by the Spark organization themselves, right? So here, if we see, so we can use spark.sql data frame join operation to perform any kind of join depending on the requirement whatever we have. So join operation, the syntax of join operation is uh, usually like this, that we give a data frame, then we do dot join, when we then we give another parameter inside join function, that is other. So this other again is a data frame that we'll be having. Then we will having that then we have a on parameter where we can give none, or we can give a string value, list value, or a column. So depending on which particular column we want to perform that particular join operation, that we are going to pass here as the parameter with the on condition. And then we have how. So how is the type of join that we want to perform. So if I scroll down a bit, and in the parameter section you can see that how usually takes a string, and it's an optional parameter, it's not a mandatory parameter. So if we don't give any if we don't pass any value to the how parameter, the default parameter will be inner. That inner join will be performed when we don't input any kind of value to the how parameter. If we want to perform any other join that we have right here, so we have cross join, we have outer join, full outer join, left join, right, and left semi, anti, and all these joins we are having. So usually we will be seeing the mostly used, whatever we use on a daily basis, I would say, or on a regular basis inside an organization, whatever kinds of joins are used, we are going to see those joins only. We are not going to see some not that useful join operations in this particular video. Again, if I talk about the on parameter, so on parameter usually takes a string. So we can pass a string, we can even pass a list. So we'll be passing a list when we want to join on more than one column. If we want to join on more than one column, then we will pass a list of those columns, and that will be passed as a parameter to the on condition. And then we are going to, like, this particular parameter is a optional parameter. So if we read here, a string of for join column name, a list of column names, or join expression, that will be nothing but a column or a list of columns. If on is a string or a list, strings indicating the name of the join columns, the column must exist on both sides, and this performs an equi join. So if you closely read this particular line, so it should be having the columns must exist on both the sides, means the column must be present on in both of the data frames, then only the join the join operation will happen, and we can perform the join operations on those two data frames. Okay. So there are now multiple examples that we'll be seeing right here in the documentation. So let's jump right onto our notebook and let's see the examples of join operations. So before writing the code, I will first of all create a markdown cell where I will write joins using Spark. Okay. And then first of all, what we'll be having, first of all, let's create some dummy data frames. So I will import the necessary functions. So from PySpark .sql, I will first of all import row, and then what I will do, from PySpark .sql, I will import functions as f. Okay, so what exactly this function as f we are doing is that we are providing an alias to this particular functions. So if you have ever worked with pandas, so what we usually do, we import pandas as pd, right? So that if I want to do some kind of, let's say, join operation in pandas, so I can just write pd.join instead of what we usually write is uh, like instead of, if I write this as pandas.join. Okay, so this is how we usually do. Okay, and then what now I will be doing is I will first of all create some dummy data frames. So let's suppose I am creating df1 will be equal to spark dot create data frame, and inside this data frame I will pass a list of rows. Okay, so row 1, so row 1 can have name. So let's say name I am giving as ls. Okay, and I am giving, let's suppose, age is equals to 2. Then row 2 I am giving name, let's say, as Bob. Okay, and I am giving age here as 5. Cool. Then I will create a new data frame df2, and here spark dot create data frame. So this is how you can usually create your own data frame if you don't have. Okay, fine. We had some kind of. So here again I can take, let's say, Tom, and now in this particular data frame I will have height. So I will take height is equals to 80. Okay. Then in the next row I can use, let's say, name is equals to Bob, and Bob height will be, let's suppose, 85 itself. Okay, let's say 85, right? And then I will create one more data frame. So spark dot create data frame. Okay, and inside this I can have, let's say, ls is this, I'm giving age, let's say, equals to 10. Okay, and then I'm having row, and I can take, let's say, Bob, name as Bob, age equals to 5, and height equals to, let's say, this time I take none. Okay, and then again I can take row as Tom, and I can take this time height, name, age as none, and height as none. And I will create one more row where I'll be having all the values as none. Okay, I will give all the values as none. Age equals to also none, and height will also be equals to none. Cool. And now what I will do is I will display all these data frames. So I will display df1, then I will display df2, and I will display df3. So let's run this. It will take a while to run, obviously. Cool. So my all the 3 data frames has been created. So the data frame 1 is having name and age column, and we are having Alice 2, Bob 5. And my data frame 2 is having name and height column. Here we are having Tom, and height is 80, Bob, and height is 85. And in the and in the database 3 we are having name, age, and height. We are having Alice, age is 10, height is 80, Bob, age is 5, height is, like, we don't have any information, so height is null. We have Tom, we don't have any information about Tom's age and height, so we are having null value. And the fourth row we are having everything as null value. Okay, now let's start with performing the different type of join operations, and we will see what is the difference between all those kinds of join operations that we are having. Okay, So what I will do, so that you guys can understand what kind of join operations we are performing, I will write a first of all comment and then I will execute it. So I can do what? I can do, let's say df underscore merged, df underscore merged is equals to, so first of all I will give df1. So this particular data frame will be considered as my left table. Okay. And then I will do join. I will do df2. Okay. And then what I can do, either I can write something like this, that df1 dot name is equals to df2 dot name, and I will just keep this particular thing only, and I will display df underscore merged. Okay. And now if I run this particular cell, let's see the output. Cool. So we have got the output, and here we are seeing that, okay, here what we'll be doing is that, okay, instead of this I can put just the name. Okay, I will just put name here and I will run this particular cell. Okay, and now you can see that the output that we are having is something as Bob, like name is Bob, age is 5 and height is 85. So let's understand why we are getting this particular cell as a output. Okay, why we are getting this particular row as an output of the inner join that we have performed on df1 and df2. So for that, let me take you to join visualizers. Okay, and I guess you must have seen these diagrams in your class 11th and 12th, where like in the sets chapter, where we were having Venn diagram as our course, right? We were having union, intersection, right, and all these things as our as the concepts that we were having. So if I do the intersection of table A, let's suppose, and table B, so let's consider A as a df1 and B as a df2, and if I check the intersection of this, so you will see that if we perform the inner join between A and B, we get the intersection of these two, maybe tables or maybe the data frames that we are having. Okay, and for the very same reason we are getting Bob, age 5 and height 85. Why? Because if I scroll at the data frame, so you can see Bob is the only name that is in both of the data frames, right? So intersection will obviously be what? Intersection will be Bob, and we have, because we have merged these two tables, right? So we are getting all the columns. So here we are getting name as Bob, age as 5 and height as 85 from the data frame 2. Okay, and for the very same reason we are getting this particular output. I guess you guys are understanding this particular concept. Okay, now let me perform an inner join, and I will use multiple columns. Okay, using multiple columns. Cool. And now what I will do is df underscore merged is equals to df1 dot join. Okay, and I can do df2, like I can join df2, or maybe let's suppose this time I join df3. Okay, and now I will be using, let's say, name and age as the columns that we are merging on. So here in the documentation we have seen that we can also pass a list as a parameter, right? So I will be passing a list of columns on which we want to merge. So the first column is name and the second column will be age. Okay, and now I'm not passing the how parameter. I'm not passing this how parameter. So by default the join will be a inner join. Okay, and now I will display this particular data frame. So I can display df underscore merged, and if I run this particular query, so you will see we are getting now this time name, age, height again, and we are having Bob 5 and null. So why we are getting this height equals to null? Because this time we have merged, or maybe I would say this time we have joined df3 and not df2. Okay, if I go here, right, and if I compare both these data frames, so the Bob is the only name that is occurring in both of these data frames, right? And now you can see that we are having Bob 5, like Bob as name as 5, age as 5, and the height of this particular like person is null. It's not available, right? So that's why the height is null right here, and the very same output we are getting here. Okay, one more thing you need to keep in mind is you can argue, right? You can argue that Bob is also, this Alice is also present in both of the tables, right? But if you look closely, so here the name of Alice, like we have the name Alice, but the age of Alice is 10 in DF3 and the age of Alice in DF1 is 2. And for the very same reason, it is not considered as the same data. It is considered as a different data. Okay. Let me just give you an example. Okay. Here, if I remove this age column, okay, here if I remove this particular age thing, like age column, and I just merge on name. So let's see the output that we'll get. So this time we also have Alice as the output. Why? Because now I'm only merging on name, right? So name is present, like name Alice and Bob are present in both of the data frames. Like Alice is present in DF1 also and DF3 also, and again Bob is present on DF1 and DF3 in both of them, and hence all of the data set is merged right here. Okay, and now you can see, because both of the columns are having, both of the data frames are having column as age, so both of the age columns are right here, and because the data is not overlapping, so we have two age columns here in our result data set. Okay, so this is the reason, like we usually like we can merge. I won't say we usually merge, but we can merge on two columns also. Okay, so I guess you got the understanding. So let me do one thing. Let me do Control Z and let me copy and paste this right at the bottom. So that you guys have output of both of the queries. Okay, here I will remove this and let me run this particular thing also. Cool. So you guys can differentiate now, right? And now let's perform some other join operations. Let's go ahead with outer join, that we also usually call as full join. So full join or outer join is one and the same thing. Okay. Now what I can do, I will do df underscore merged will be equals to df1 dot join. I will join df2 and I want to join on name column. And how I want to join? So now I will explicitly, I will have to pass the condition as outer. Okay. And now I can display df underscore merged. And now if I will run this, so just see the output that we will get. Okay. Now what we are getting is all the rows from df1 and all the rows from df2 with the combined data. And if we don't have any values in, let's suppose, df1, like we don't have any information so for Tom we don't have the age information in df1, right? So if I go here, so Tom is not here in the df1, right? Tom is not in df1, so we don't have any information of Tom's age. So that for that reason we are getting null. Whereas Alice is not in df2, so we don't have any information of Alice's height. So that for that reason Alice height will be shown as null in the output of this particular join operation. Okay, so how full or outer join is performed is, if I again go to my visualizer. Okay, so if I remove this and if I select these two things, means I am selecting my data frame 1 and I am selecting my data frame 2, right? If I select both of my data frames, so now as the output what I will get is the full outer join operation. Okay, and the very same operation I have performed right here in this particular cell. Got it? Now let's perform a left join. So now I want to perform left join. Okay, so what I can do now is df underscore merged will be equals to df1 dot join. Okay, I can join df2 again, and now I will just give something like this: name, and I will do comma and I will just write left. Okay, I'm not explicitly defining how, I am just writing left. So let's see if it works correctly or not. And if it work correctly, then how it is working correctly. Okay. So we have got the output and we are getting the correct output, right? And now what we are getting is we are only getting the rows from df1, that is the left table. So I can consider this df1 as the left table and this df2 as right table. Even in the documentation, if you go right here, so this other data frame is considered as the right side of the join. So obviously this particular data frame that is before the join function will be considered as the left side. Okay, so here I am using left join. Okay, so left join will be done what? So only the rows from left uh, of the left of the table of the left table will be picked up and it will be joined with the right table. So here it has joined the height column right here. So because we are having Bob in the df2 also, we are getting the information of Bob's height, whereas as we have seen that Alice is not present in df2, so the output of the height of Alice's we have got as null. Okay, now you can say you can think that how this particular like without passing this how is equals to left, my query ran successfully. It is because if I go right here, so you can see the order, right? How, like what the order we have to pass the parameter in. So the very first parameter will be the data frame. So that's what we have passed, right? The second parameter will be the on condition or the column that we want to pass. So we have passed the column, right? And the third parameter will be considered as how. So we have passed this how condition. Okay. If you are not explicitly passing the values or the parameter right here, so it will consider in that particular order. Okay. But if by mistake I do it something like this, that instead of name I pass left and instead of left I pass name. Okay, if I do this, so let's see what happens. Now we are getting an error and it's showing saying unsupported join type, and we are getting name as the join type, that it's unsupported. Why? Because there is no kind of join operation that is named as name. Okay, so now what we can do is if we want to keep the parameter as this particular condition only, so now I can explicitly pass. I can do on. Okay, sorry, instead of left I can do how. So I want to perform left join and I want to perform left join on name column. And now if I run this, so it will run absolutely fine. Okay, so this is one of the reasons if we want to use these parameters, so we can use it in any order. And if we are not using these parameters right here explicitly, so we have to maintain the order in which it is right here in the functions documentation. Okay, so you have to keep these things in your mind. Now I can perform a right join. Let's see. Okay, let's first of all visualize the left join. Okay, so if I'm only picking up the left table, if I'm only picking the left table, so you can see we are doing a left join. And now if I only pick the right table, so we will be doing a right join. So all the rows from right table will be joined with the table that we are having on the, like on whatever table we are joining on. So I can do what? Df underscore merged will be equals to df1 dot join with df2 and I will take name and right and df merged. So now all the rows from df2 will be picked up and it will be joined with the column on the df like column in the data frame 1, and whatever information we are having we will get that information, else we will get null as the value. So here in data frame 2 if you see, so we don't have Tom in data frame 1. So we don't have Tom in data frame 1, hence we don't have any information about Tom's age. So we got null as the output, and Bob is present in both of the data frames. So we got all the information regarding Bob in the row 2 of our data frame. Okay. Now let's perform a semi join, left semi join. Okay. Now we will perform left underscore semi join. So how it will be performed? Df underscore merged So this particular join is hardly used. So honestly, like even I have never used this particular join in my organization ever. Okay, so but let's see how we can do. So left underscore semi I will be doing. Okay, and I will display df merged. Okay, and let's run this. Cool. So now you can see that we are only getting Bob. Okay, so if I scroll at the top, okay, and if I compare both of these two data frames, that is df1 and df2, okay, so you can see on Bob is the only thing that is that is in the both of the I would say both of the data frames, and hence we are getting this particular output as Bob 5 and Bob as name and age as 5. Right? It has not picked up any kind of information from the df2 column. Okay, and for that reason it's saying as left semi join, because it will only pick up the left side's information only. Okay, then we can do left anti join. There is also a join that is called as left anti join. So again, this particular join is also rarely used. Okay. So df1 dot join, I can join on df2. I will again join on name column, and this time I will perform what? I will perform left anti join. Okay, and then I will display my df underscore merged. Okay, df1, not df1 dot join. So now you will see that we are getting Alice and age. Means if we go at the top, so this time Alice is the only row that is not present in, like Bob is present in both of them. So we are doing the anti of it, right? So that is not present in data frame 2. We will get the information of those rows. Okay. So we are getting Alice and Alice name and age 2. So we have performed left anti operation in this particular join. Okay. Now let's perform something called as cross or Cartesian join. Okay, so this is one of the most resource consuming join that we are having. Okay. It is Cartesian, Cartesian, Cartesian join. Okay. So how this join is usually performed is df underscore merged will be equals to, okay, it will be equals to df1 dot join. Okay, and this time we will do df2, and we will not pass any column name. We will just do how is equals to cross join. That's it. Okay, and now we will and the output itself will explain you why we are now not passing any kind of column right here. And let's just run this particular cell. So we are getting this output now. Okay, we are having name, age, name, height. Okay, we are having Alice2, Tom this, Alice2, Bob this, Tom this, Bob this, and Bob this. What is this? You guys might get confused, right? Like it's not making too much of sense. But let's scroll at the top and let me show you how this particular cross join or Cartesian join is performed. So cross join or Cartesian join is performed something like this, that Alice will be joined with the row 1 will be joined with all the rows of df2 firstly. Okay, so Alice is joined with first of all Tom. So we are having Alice2 Tom 80. Then Alice is joined with second row, that is Alice2 Bob 85. Okay, so I guess now it's making sense. Then in the third row as an output we will get Bob 5 Tom 80. Okay, we will get Bob 5 Tom 80, and again Bob will be then joined with the second row of Bob like of the data frame 2. So it will be Bob 5, Bob 85. Now you get the sense why we are getting this particular output as this. Okay, Alice 2, Tom 80, right? Then Alice 2, Bob 85. It has, so the row 1 of my data frame. So this is my row 1 of my data frame 1, right? So it has joined with, first of all, row 1 with data frame 2 and row 2 of data frame 2, correct? And then this is my row 2 of my data frame 1. So it has joined with, it has joined with, first of all, row 1 of my data frame 2 and then row 2 of my data frame 2. So this is how cross join is performed. I guess you got the intuition behind the cross join. Then there is also a kind of join that is called as self join. Self join. So as the name itself suggests that the table or the data frame will be joined by itself only. Okay, so we will join df1 with df1 itself. Okay, something like this we will perform. So usually how it is performed is, first of all, we will take an alias kind of thing. So I can keep left as df1 dot alias as left, okay. Then I will take an alias as right. It will be equals to df1 dot alias as right, okay. And then what I will do is that left dot join, I will join on right, okay. And then I will do what? I will join on, let's suppose, name column. And how I will join? I will join on cell, okay. And now if I will, let's take as df underscore must, the output of this. Now if I display, okay, it's df underscore merged, merged, okay. If I display df underscore merged, so let's see the output here. Okay, unsupported. Okay. Okay, cool. Got it. Here instead of this self join, I will be doing what? I will be doing inner join. Okay. And now let's run this. Cool. So now what we have got is, we have got name, age and age. Okay. So we have self joined this. Like we have self joined df1 with df1. So for that reason we have got name of that particular like this is my df1, let's suppose, right? And this name and this age column is my df2. If I consider, obviously both are df1, but if I consider this name and this age column is my df2, again for row 2 this is my df1, and this bob and this third column is my df2 if I compare it with some other kind of joins. So this is how self join is usually performed. Okay. Then there is one more kind of join that we are having, is a broadcast join. We have something called as broadcast join. So let's first of all see how we can perform a broadcast join, and then I will let you know what exactly broadcast join is. Okay. So from PySpark.sql dot functions, I will import broadcast. Okay. And then what I will create two data frames. First of all, let me create a small data frame. Okay. And I will do something as spark dot create data frame. Okay. I will keep row. So I will keep k is equals to 1 and value is equals to, let's suppose, a. Okay. And now I will create a large data set. So I will use spark dot range. So let's take the value as, let's say, 10 million. Okay, I guess it's 10 million. V and 10 million, correct. Okay. So now, and then what I will do is select expr, and I will take id as k, and id as well also as v also. Okay. So what it will do is it will perform like it will create id column. It will give 1 to 10 million value. It will take create a v column, and it will put this particular v column from 1 to 10 million. Okay. And now if I even display you guys, I will display small, and I will display large. Okay. And let's display this and display large. Okay. And if I run this, so you can see this is my df1. Okay. And this is my df2. So we are only having here 10,000 rows that we can see, but it has created 10 million rows, okay, in df2, right? So first of all, let's perform a regular join. Okay, let's perform a regular left join. I will perform a left join. Okay, so if I do, let's say df underscore merged itself is equals to small dot join, and I will join large, okay, on let's say id column, or let's say v column. Okay, okay, no, we are having only id here, right? So on id, okay, and here what I will do is just a second, is there, we are having k as 1 and v as a. Okay, fine. Okay, and we will perform here on k. Then I am having how I will perform, and I will give a left join, and let's display df underscore merged. Okay, and let's run this. Okay, k cannot be resolved. Okay, it's giving underscore 1. Why? So we are creating the small data frame. Create data frame row k is equals to 1, and this k this we have to change now. Okay. Cool. So now we have k and this. Okay, and instead of this val we will have v, obviously, right? Cool. So now the data frame is correct. And now if I run this, okay, so you can see that we have got the output as k, v, and v. Okay. So this is the usual join that we are performing, right? So we have performed a left join right here. Okay. Let's go ahead and perform a right join now. Okay. And let's see if it is taking a long time or not. Okay. So in performing the right join, it has taken a bit long time. Why? Because the data shuffling was happening from large to the small data frame. Okay, for joining operation, right? And for the very same reason, it has taken around 1 second of times, 1 second of time. If I do the very same thing using broadcast join, okay, now if I will do broadcast join, so df underscore merge is equals to small dot join. Okay, I will join. Sorry, I will this time now do large dot join, and let me join using a broadcast. Okay, I will broadcast what? Broadcast small. Okay, on column K, and how I will do a left check. Okay, and let's display df underscore merged. And if I run this now, okay, so it has taken a bit long time, 1.79 seconds. But let's do again this particular operation. So earlier we had performed like this, okay, and now if I remove the broadcast part of it, maybe due to caching and all, so it can like run earlier also. Obviously, it has run earlier. So it has now taken. Okay, let me do one thing. Let's compare cached with cached. Okay, so it has taken this time 1.24 seconds. Okay, and now if I run this broadcast join again, okay, so let's see how much time it will take. Is it? It has run again. Okay, so this time because the data has been cached, right? Sorry. Yeah. So this time because the data has been cached, it only took 0.94 seconds to run. Okay. So it means the broadcast join performed better as compared to the usual join. So what usually happens in broadcast join is that we don't shuffle the larger data to the smaller data. What we usually do is we overlap the smaller data, or we shuffle the smaller chunk of the data to the larger chunk of the data frame. So this usually happens when we have a master slave kind of architecture or a distributed architecture where the data is stored on multiple nodes. So this particular join will be very helpful on in those particular conditions. Okay. So what is the definition of small here? So small here defines 10 MB. So if the data frame's size is less than 10 MB, we can easily perform a broadcast join. If the other data frame or the larger data frame is very large. Okay. Here because we are having only two columns, so even the large data frame is not that large. But if we will be having like, let's suppose 10 million rows, right? And let's suppose we have hundreds of columns. In that particular case, it will take a very long time for the normal join to run. It can take like a few seconds to run. Here it's only taking, let's say, 1 point some seconds. But if you are having hundreds of columns, it will take a few seconds or maybe a minute to run that particular join operation. Cool. So I hope you learned something new in this particular video. So let's meet in next video. Till then, keep learning and keep growing. Bye bye.